Welcome to Brain Vision.
In this particular question, we are assuming we have a very large tank and we have a blackbody object that is submerged inside of a pool of a tank of water. We want to find how much water is being evaporated due to only the blackbody radiation that is actually emitting from this body. Now we're going to ignore everything that is actually transferred by conduction or convection, so only radiation transfer of energy, so kind of like they are not really touching, right? Except that they are, but we ignore the conduction part. So what is the amount of energy being transferred per second, right? We can use the Stefan-Boltzmann's law for the power radiated. That is the power is given by the Stefan-Boltzmann's constant multiplied by the surface area multiplied by temperature to the power 4. Now the thing is, the water itself gains this amount of energy, right, from the sphere, but it also loses a certain amount of energy based on its own temperature, right? So this is the water's area, surface area, and water's temperature. Now we're going to assume that it only radiates its power in this area, right? It radiates back to the sphere, so they will have the same surface area, A, although it doesn't really make sense, right? But we don't know what is this surface area of this. And we're going to assume maybe it's perfectly insulated, but this is not given, so we cannot use that surface area. We only can use the surface area of the sphere, right? And of course the temperature of the water. So now we can equate this, right? This would be the power of the water, right? So the energy being absorbed by the water must be equals to the rate of change of our mass multiplied by the latent heat of vaporization, right? Since this is what causes the water to vaporize, right? And if we multiply the mass, right, change in mass times the vaporization, this will give us the energy, right? Total energy absorbed, and over time will give us power. Right, so actually we can equate these two together. So we have sigma A times temperature of the sphere to the power 4 minus temperature of the water. We are assuming that the water is at boiling point already, right, which is basically 100 degrees Celsius. So we can rearrange this equation to find the rate of change of our mass of water. Just have to divide the latent heat of vaporization over, and we can replace the surface area A 4 pi r squared, where r would be half of the diameter that's given, so that's 0.12 meters. Sigma, the constant, 5.67. Temperature of the sphere is 225 degrees, just 498 kelvins. And we take 273 plus 225 power 4 minus away temperature of the water, which is 373, assuming it's at boiling point. Divide this by the latent heat of vaporization, which is 2256 times 10 power 3 joules per kg. Right, and we should get 1.92 10 power minus 4 kilograms per second. So this is the change in the mass per second, or just 0.193 grams per second. Now we want to actually measure the various properties of the black body, or the spherical black body that is emitting this energy, right? You want to find what is the peak intensity of the wavelength. Sorry, peak intensity. Yes, correct. The wavelength of the peak wavelength, the peak intensity, and also the frequency. So we can use Wayne's displacement law, where the peak wavelength is given as a constant divided by the temperature. Temperature is given as 498 kelvins. This will give us 5.82 times 10 power of minus 6 meters. Now, however, our organism is in water, right? This wavelength is in air or vacuum. Right, if you are in water, the wavelength would actually be slightly shorter. And the reason is because there's the presence of water molecules that would slow down our light, right, causing it to change its wavelength due to the bouncing of the light, right, refraction of the light. So the actual peak wavelength in water will have to divide this by the optical density N, which is 1.333. This is for water, so this is about 4.37 micrometers. On the other hand, for the frequency, right, the frequency would not be changed, right, whether you're in water or in the air, right, or in vacuum. So this doesn't change, it's just C over the original peak wavelength. And you get frequency of about 5.15 times 10 power 13 Hertz.